Ladies and gentlemen, what I'm about to share with you represents one of the most extraordinary astronomical events of our lifetime. I'm Dr. Michio Kaku, and throughout my career as a theoretical physicist, I've witnessed countless cosmic phenomena that have challenged our understanding of the universe. But nothing, and I mean nothing, has captivated the scientific community quite like the arrival of 3I Atlas. When the Atlas telescope system in Chile first detected this object on July 1st, 2025, I remember receiving the preliminary data at 3 a.m. I was in my study, reviewing equations for a lecture on string theory, when my phone lit up with messages from colleagues around the world. The astronomical community was in an uproar. What we were seeing shouldn't exist according to our conventional models of interstellar objects. Let me paint you a picture of what makes this discovery so profound. 3I Atlas is only the third confirmed interstellar object ever observed passing through our solar system. Think about that for a moment. In all of human history, with all our telescopes and all our technology, we've only confirmed 3 visitors from beyond our cosmic neighborhood. The first was Oumuamua in 2017, which sparked worldwide fascination and debate. The second was 2I Borisov in 2019, and now we have 3I Atlas. But this one is different. This one is challenging everything we thought we knew. I've spent countless hours in coordination meetings with NASA, ESA, and observatories worldwide. The data we've collected is both thrilling and deeply puzzling. This object is traveling at approximately 137,000 miles per hour through our solar system on a hyperbolic trajectory. That means it's not bound by our sun's gravity. It's merely passing through, like a cosmic traveler on an eternal journey through the galaxy. But here's where it gets fascinating. This velocity, this trajectory, this entire encounter suggests that 3I Atlas has been wandering the Milky Way for potentially billions of years. When I analyze the spectroscopic data from the James Webb Space Telescope observations conducted on August 6, 2025, I see something that makes my physicist's heart race. The chemical signature of this object is bizarre. We're detecting massive amounts of carbon dioxide, carbon monoxide, water ice, and even carbonyl sulfide streaming from its surface. But the ratios are all wrong. They don't match what we see in comets born in our solar system. It's as if this object formed under completely different conditions, perhaps around a star with a different metallicity, perhaps in a region of the galaxy where the fundamental chemistry of planet formation operated differently. Let me share with you what keeps me up at night. My colleague Avi Loeb and his team have calculated something extraordinary. By tracking the object's movement with incredible precision, using over 4,000 observations from 227 observatories worldwide between May and September 2025, they've discovered that 3I Atlas shows virtually no non-gravitational acceleration. Now, for those of you who aren't astrophysicists, let me explain why this is revolutionary. When a comet approaches the sun, the heat causes ice on its surface to sublimate, to turn directly from solid to gas. This creates jets of material that act like tiny rocket engines, pushing the comet slightly off its gravitational trajectory. We call this non-gravitational acceleration, and every comet we've ever studied exhibits it. Every single one, except 3I Atlas. The implications are staggering. If this object is shedding material, and we can clearly see that it is, but showing no measurable non-gravitational acceleration, then by the laws of physics, by the principle of conservation of momentum, this object must be extraordinarily massive, far more massive than anything we expected. My calculations, combined with Loeb's analysis, suggest that 3I Atlas has a mass of at least 33 billion tons. That's 3 to 5 orders of magnitude more massive than the previous interstellar objects we've observed. Think about what this means for our understanding of planetary system formation. If objects this large are being ejected from other star systems and wandering through interstellar space, Wax, Gerb, then the dynamics of planet formation across the galaxy must be far more violent and chaotic than our models predict. This single object is forcing us to rewrite our textbooks on how solar systems evolve. But here's where it gets even more intriguing. On October 3rd, 2025, 3I Atlas made its closest approach to Mars, coming within just 18.6 million miles of the red planet. Multiple spacecraft, ESA's Mars Express and Trace Gas Orbiter, NASA's Mars Reconnaissance Orbiter, were positioned to capture this historic moment. I was in mission control at the Jet Propulsion Laboratory when those images came through. The tension in the room was palpable. We were witnessing something that happens perhaps once in a human generation. The gravitational interaction between 3I Atlas and Mars was negligible. The gate velocity change imparted to Mars was less than 2 trillionths of a meter per second, completely unmeasurable. Yet this very fact tells us something profound about the nature of gravity itself and the mass distribution of this object. When I analyze the rotation period, 1616 hours, and compare it to the mass estimates and size constraints, something doesn't add up. The internal structure of this object may be unlike anything we've encountered before. I've collaborated with colleagues at Harvard, MIT, and institutions around the world, and we're all asking the same questions. How did an object this massive get ejected from its home star system? What kind of planetary architecture would produce such an ejection? And perhaps most intriguingly, what is the internal structure of this object? The Hubble Space Telescope images from July 21st revealed something we've never seen before. A teardrop-shaped cocoon of dust pointing toward the sun, not away from it as we would expect. The physics here is straightforward. The dust particles are too large and heavy to be pushed back by solar radiation pressure. Instead, internal activity is ejecting them in the direction of the sun's warmth. It's a subtle effect, but it speaks volumes about the composition and behavior of this interstellar wanderer. As I write this, 3I Atlas is approaching its perihelion, its closest point to the sun, which will occur around October 30th, 2025. At that moment, it will pass just inside the orbit of Mars at a distance of about 130 million miles from our star. The solar radiation at this distance will increase the sublimation rate dramatically. We're expecting the coma, the cloud of gas and dust surrounding the nucleus, to expand significantly. Current observations show it's already about twice the diameter of Earth, but it will grow much larger. Now, let me take you on a journey into the implications of this discovery, because what we're witnessing with 3I Atlas isn't just about one object passing through our solar system. It's about understanding our place in a dynamic, interconnected galaxy where matter, energy, and perhaps even life itself travels between the stars. As a theoretical physicist who has devoted my career to understanding the fundamental nature of reality, I can tell you that encounters like this one force us to confront the limitations of our knowledge. We like to think we understand how the universe works. We have our equations, our models, our theories. But then nature throws us a curveball like 3I Atlas, and suddenly we're scrambling to explain observations that don't fit our preconceptions. The scientific community is currently engaged in one of the most spirited debates I've witnessed in decades. The data points to something extraordinary, an object that appears to be far denser or far more massive than conventional comet models would predict. Some researchers, including my esteemed colleague Professor Loeb, have even raised the possibility, however remote, that we might be looking at something artificial, perhaps a probe from another civilization. Now, I want to be clear here. As scientists, we must follow the data wherever it leads, but we must also apply Occam's razor. The simplest explanation that fits all the facts is usually correct. But what are the facts? Let's examine them systematically, as any good physicist would. First, we have the trajectory. 3I Atlas's path through our solar system brings it remarkably close to Mars, Venus, and positions it for an eventual encounter near Jupiter in March 2026. The statistical probability of such a trajectory occurring naturally has been calculated at roughly 0.05%. That's 5 in 100,000. Not impossible, but certainly noteworthy. Second, we have the chemical composition. The ratio of nickel to iron in the material streaming from 3I Atlas is unusual, more consistent with industrial nickel alloys than with natural cosmic abundances. The predominance of carbon dioxide over water is also atypical. These facts don't prove anything extraordinary, but they demand explanation. Third, and perhaps most puzzling, is the polarization of light we observe from the object. Extreme negative. Polarization has been reported by multiple independent observing teams. In my experience studying astrophysical phenomena, such polarization signatures typically indicate very specific surface properties or internal structures. Now, I want to address something that's been circulating in social media and popular press. You may have heard sensational claims about this object bending time, or warping space-time near Mars. Let me be absolutely clear. While every massive object does create a gravitational field that technically curves space-time, this is the EA, foundation of Einstein's general relativity, which I teach to graduate students. The effect from 3I Atlas is utterly negligible. The space-time curvature produced by this object is trillions of times smaller than that produced by Mars itself, and Mars's gravitational field is only a tiny fraction of Earth's. So let's put those sensational claims to rest right now. What we are dealing with is something potentially more interesting than science fiction scenarios. We're dealing with a natural laboratory that's teaching us about the formation and evolution of planetary systems across the galaxy. The fact that 3I Atlas has such unusual properties tells us that the cosmic environment where it formed, perhaps 3 to 14 billion years ago, based on preliminary age estimates, was different from our solar system's birth environment. Think about the journey this object has undertaken. For billions of years, it has drifted through the interstellar medium, perhaps passing within light years of thousands of star systems, experiencing the subtle gravitational tugs of countless stellar encounters, accumulating surface materials from the tenuous gas and dust between the stars. It's a cosmic time capsule, carrying information about regions of our galaxy that we cannot easily access by any other means. The observations we're conducting right now will shape astronomy for decades to come. The James Webb Space Telescope is scheduled to make follow-up observations in December 2025 after the comet's perihelion. The Hubble Space Telescope will perform ultraviolet spectroscopy in November to determine the sulfur-to-oxygen ratio in the gas emissions. These measurements will help us understand not just 3I Atlas itself, but the chemical evolution of the Milky Way. And here's something that excites me tremendously. We're now entering an era where interstellar objects may become routine discoveries. With powerful new survey instruments like the Vera C. Rubin Observatory coming online, we expect to detect perhaps dozens of interstellar visitors in the coming years. Each one will be a messenger from distant stellar systems, carrying clues about planetary formation processes operating in different regions of our galaxy at different times in cosmic history. What does this mean for humanity? It means we're beginning to understand that our solar system is not isolated. We're part of a galaxy-wide ecosystem where material is constantly being exchanged between star systems. The building blocks of planets, and perhaps even the ingredients for life, are not confined to their birthplaces. They travel, they spread, they seed new worlds. This is the grand vision that keeps me passionate about physics after all these years. We're not just studying cold, dead rocks tumbling through space. We're studying the mechanisms by which the universe creates complexity, diversity, and possibly life itself. Every interstellar object is a thread in the cosmic tapestry, connecting star systems across vast distances and immense timescales. As I prepare to deliver lectures about 3I Atlas to audiences around the world, I'm reminded of why I became a physicist in the first place. It's moments like these, when humanity collectively witnesses something unprecedented, when our instruments capture data that challenges our understanding, when we're forced to think bigger and reach further. That make me grateful to be alive in this era of discovery. The story of Three Eye Atlas is still being written. As I record these thoughts, the object is behind the Sun from Earth's perspective, hidden from our ground-based telescopes, but still under observation by spacecraft scattered throughout the solar system. When it emerges into view again, in early December 2025, we'll have new opportunities to study it as it races outward, accelerating away from the Sun's gravity well, eventually returning to the vast darkness of interstellar space. And here's the beautiful, humbling reality. After all our observations, all our measurements, all our analysis, Three Eye Atlas will leave our solar system carrying most of its secrets with it. We'll have learned something. We always do. But we'll also be left with new questions, deeper mysteries, and a renewed sense of wonder at the complexity and beauty of the cosmos. This is the nature of science. Every answer opens doors to new questions. Every discovery reveals how much more there is to discover. And every interstellar visitor reminds us that we live in a universe far stranger, far more diverse, and far more magnificent than we ever imagined. As Three Eye Atlas continues its eternal journey through the galaxy, I can't help but wonder, how many other star systems has it passed? How many alien suns have warmed its ancient surface? And perhaps most intriguingly, are there astronomers on distant worlds who have watched this same object pass through their skies, asking the same questions we're asking now? These are the questions that drive science forward. These are the mysteries that will inspire the next generation of physicists, astronomers, and explorers. And these are the moments, rare, precious moments like the passage of Three Eye Atlas, that remind us why we look up at the stars in the first place. The universe is speaking to us, ladies and gentlemen. All we have to do is listen. Dr. Michio Kaku is a theoretical physicist, futurist, and professor of theoretical physics at the City College of New York. These observations represent his personal, scientific analysis of the Three Eye Atlas encounter, based on data available through October 2025.